Hey everyone, Morgan here. So we are on the first page of the Thermodynamics lecture outline for AP Chem. And I want to begin with a quote from probably the most famous physicist that you've never heard of, Arnold Sommerfeld. He was basically Einstein's boss and Max Planck's boss back in Germany in the early part of the 1900s. And Sommerfeld once said, "Thermodynamics is a funny subject. The first time you go through the subject, you don't understand it at all. The second time you go through it, you think you understand it except for one or two small points. The third time through it, you know you don't understand it, but by that time you are so used to it that it doesn't bother you anymore." And this is definitely a pretty accurate quote. All right, thermo is a tricky subject. There is a lot to it. And this is a little bit different than what we did early in the year. This is not what we call thermochemistry. This is thermodynamics. It is the study of heat transformations. However, I've never been terribly happy with that definition. I think what thermo really is a question of spontaneity. So we are going to approach this topic and this whole chapter with one guiding question in mind. If left to itself, will a given reaction happen without outside influence? That means, is it spontaneous? Spontaneity, the quality or state of being spontaneous. That's Webster's Ninth New Collegiate Dictionary. That is not very helpful. In fact, that breaks one of the first rules that we teach in school about defining words. Never use the word to define the word. So for us, a spontaneous process is one that will proceed on its own without further input from the rest of the universe. One that is thermodynamically stable. And we're going to get used to the phrases thermodynamically stable and thermodynamically favorable. Now, spontaneity has nothing to do with time. I need to point something out about that. We studied reaction rates. We did a chapter about kinetics. Now, we know for a fact that diamonds are not thermodynamically stable. If you leave a diamond be, don't touch it and just let it sit, it will spontaneously turn back into graphite. However, it takes something like 100 million years for that to happen. So don't worry, your diamonds are not all going to suddenly go poof and disappear. So these discussions have nothing to do with whether something happens quickly or slowly. That was the kinetics chapter. This chapter just deals with whether or not it is going to happen. And there are three factors that we need to pay attention to: enthalpy, entropy, and temperature. These are the three factors that will determine spontaneity and whether or not something is thermodynamically favorable. So temperature is the easiest one for us to deal with. Let's get that out of the way right now. Let's imagine that we have three identical beakers with three identical amounts of water and three identical ice cubes that are in each of these beakers. We will alter the temperature. This one will be at -1 degrees Celsius, this will be at 0 degrees Celsius, and this will be at 1 degree Celsius. Now, what happens in these three beakers is very different because of the difference in the temperature. Let's begin by talking about the one on the far right, the one that's at 1 degree Celsius. That ice cube's going to melt. Now, it might not happen instantly. It's going to take a little while, but it is going to melt. We know that. And the one that's at negative 1 degree Celsius, that ice cube's going to grow. It's going to get bigger. And this one at 0 degrees Celsius, as long as it is maintained at 0 degrees Celsius, nothing's going to happen. It's basically just going to be an equilibrium situation. Okay? So temperature has a big effect on spontaneity, and sometimes the temperature changes don't even need to be very large. Okay, that's page 1. Thanks for tuning in. This is Morgan, signing off.